Good morning, students. HS second year mathematics class now. Application of derivative chapter 6 we will do, and already we have started exercise 6.1. I think we have up to question number 8 we have done. Now we will start question number 9. Question number 9 said a balloon which remains spherical has a variable radius. Find the rate at which volume is increasing with the radius when the radius is 10 centimeter. So you see, volume of a balloon at which it is increasing, that is rate of change of volume with respect to radius, we have to find. So we know volume V of sphere, it is what? 4 by 3 pi r cube. Then rate of change of volume with respect to radius they have said. So dV, of course here where r is equal to radius of balloon. So dV dr is equal to differentiation of these things. 4 by 3 pi, it is what? Constant. You will take outside, and dr cube, dr is right. Then it will be 4 pi by 3 into 3r square. 3 cancel. Then they have given r as what? 10 centimeter. So if we put 4 pi 10 square, it is given, so it is 400 pi cubic centimeter by centimeter. So this is the answer. This is our question number 9. So now we will move for question number 10. So not so tough sum, we will try to do. Question number 10. A ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 meter per second. How fast is its height on the wall decreasing when the foot of the ladder is 4 meter away from the wall? So suppose this is our one building, suppose you find. So this is building. Here on the ground one ladder is kept. So length of the ladder they have given, it is 5 meter long. Then someone has pulled this way. The automatically ladder will what? Slip, and it will, upper portion will decrease. Upper portion will slip, and automatically this length will decrease. If I give the name, ladder is suppose AB, and this suppose height is AC, then you see that if we take now, ladder length cannot be changed, but this length as well as that length will also change. So we will write like that, let base as shown in figure, it will be very shown in figure. Base is suppose x meter you have to take, and suppose this length is y meter. Height, it is y meter. Now we know there is a relation between this length and base and this. This is a right angle triangle. We know by Pythagoras theorem, in right angle triangle, hypotenuse square is the sum of the square of other side. So we can write now by Pythagoras theorem AB square is equal to x square plus y square, and this implies y is root over AB is what? 5, so 25 by 25 minus x square. So this is your by Pythagoras theorem, this one. They said what? That rate of change of y with respect to time. So we will do what? Now we want to find rate. Its rate is dx by dt is given as what? As this rate at which 2 meter per second. This is dx by dt they have given 2 meter per second. dy by dt they have asked. Now also dy by dt, it will be what? Differentiation of this one. Then using chain rule, it will be 1 by 2 root over 25 minus x square. And differentiation of this one, again we have to do, and it is 25 differentiation is 0 and minus x square is twice x. I want to repeat it again. dy dt they have asked. Then if we differentiate this one with respect to chain rule, it will be 1 by 2 root over 25 minus x square using the chain rule. Then again we have to differentiate this, it will give minus twice x, then dx dt. Cancel. They have given what? X, value of x also given, and dx by dt also given. X they have given 4. So if we put this one, root over 25 minus 4, that is 16 minus 4, and dx by dt they have given 2. So after calculation we will get here, this is 25 minus 6 is 9, so minus 8 by 3, because 9 becomes this meter per second. So this is your answer. So it is not a very tough thing. So this is our now question number 11. A particle move along the curve 6y is equal to x cube plus 2. Find the point on the curve on which y coordinate is changing 8 times as fast as x coordinate. What they have said? They have given 6y is equal to x cube plus 2. Now, one thing you have to think that y coordinate is changing 8 times as fast as x coordinate. This means what? dx by dy by dx is what? 8. That meaning of this one, y coordinate is changing 8 times as fast as x coordinate means dy dx is 8. Now at that value of dy dx is equal to 8, you have to find the value of x and y, that is point of coordinate. That first you have to think that what they have asked. Okay, first our work is to differentiate. If we differentiate, then after differentiation this will be 6 dy dx. With respect to x we are differentiating. This if we differentiate, it is 3x square, and differentiation of 2 is 0. When dy dx is equal to 8, already given, then 6 into 8 is equal to 3x square. So we get x as 16, so plus minus 4. So we found value of x when dy dx is 8. Then for this value, what will be the value of y? For x is equal to plus 4, y will be what? 4 cube, 64, plus 2, 66 by 6, that is 11. And for x is equal to minus 4, y becomes minus 4 cube is minus 64, plus 2 minus 62 divided by 6. 62 by 6. So I think you can cancel by 2. It is 31 by 3. So it is minus 31 by 3. So required points, that what points they have asked is 4, 11 and another is minus 4 by minus 31 by 3. So this is our question number 11. So I think you understood this one. Now we will go over to our question number 12. So question number 12, what they say, the radius of an air bubble is increasing at the rate half centimeter per second. At what rate is the volume of the bubble increasing when the radius is 1 centimeter? So first we do radius of a bubble is increasing. It is dr by dt is equal to half centimeter per second. Volume of the bubble is increasing, that we have to find. That is dV by dt. They have asked. So we know volume is what? 4 by 3 pi r cube, which is 50. So 4 by 3 pi 3 r square dr dt. Now we will put all the values. 4 pi r square. R is given, they have 1 square, and dr dt is half. So it is twice pi. Of course, here unit will be volumes cube is centimeter cube, and per with respect to times it, so centimeter cube per second. So this is our question number 12. So that is not a tough one. We will just think of what is given and what we have to do. If we just trace out, then we can easily find the way. Now question number 13. Question number 13, they say a balloon which always remains spherical has a variable diameter 3 by 2 into twice x plus 1. Find the rate of change of volume with respect to x. Variable diameter. Diameter, that is given radius r is equal to, as diameter is given, so we will give half of 3 by 2 twice x plus 1. What I have done, diameter is given this one, I use half, so it makes radius. Then they say rate of change of volume with respect to x. For that, what we have to do, dr dx, first we find it is 3 by 8, and differentiation of this one only give 2, 1 is 0. After cancellation, 3 by 4, and it is up to this one. Now, rate of change of volume with respect to x, that is d 4 by 3 pi r cube with respect to x. 4 by 3 pi r cube is 3 r square. As variable and these are not same, you have to differentiate r with respect to x again. Now, for the value of r, it is r already given this one, so we will put these things. 4 pi, r is this, so it is 3 by 8 square, 9 by 64 twice x plus 1, and dr dx already we have calculated 3 by 4. Now 4 cancel and we get 27 by, I think, radius square 4 by 3, so 3r square, r is this, so okay, what is answer? 64 twice x plus 1 whole thing square. I have to little check it again. R is given 3 by 4 twice x plus 1, so this radius, rate of change of radius with respect to x, 3 by 8 will come again, and here 2. So here I have done one mistake. No, it is 2 cancel, it is 3 by 4. 4 by 3 pi r cube. 4 by 3 pi is constant, and it will come out, and r cube is 3r square dr dx. 4 by 3 cancel, 4 pi, then r square, its square, 9 by 8 64, and twice x plus 1 square. This one is, if we differentiate, then it is 3 by 4, 4 cancel, yes it is correct, this is 27 by 64, twice x plus 1 whole thing square. Okay, now we move for question number 14. Question number 14 is said, sand is pouring from a pipe at the rate of 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way that the height of the cone is increasing 1/6 of the base. How fast height the sand cone increasing when height is 4 centimeter? See, suppose someone is pouring the sand. So if someone pouring the sand, then it will come and it will form like a cone. It is sand is pouring, and so this is a cone forms. At the rate of for 12 centimeter cube per second, that means volume of sand is increasing 12 centimeter cube per second. The falling sand forms a cone on the ground in such a way the height of the cone is always 1/6 of the base. That is, here if we take radius as r and height of this one is suppose h, what they have given, that height of the cone is always 1/6 of the base. H is 1/6 of r. It is they have given. And how fast height of the sand increasing when height is 4? So first we will do this one. Volume of cone B is equal to, one formula we have learned in class 10, 1 by 3 pi r cube h. Already we know this one. Here, as we have a relation between h and r, so we will change r by h. So r if we change by h, so we will get rate of change of, first we found we have to, they have given dV by dt is 12 centimeter cube per second. Also they have given h is equal to 1/6 r. Then height of the sand increasing when, how fast height of the sand increasing? Meaning is what? Height they have given 8. We have taken it. dh by dt we have to find. So as we need this one, better we change all the r by 6. It is given this one, so we will find r as what? 6h. So 1 by 3 pi r cube 6h whole thing cube h. 6 cube means 6 into 6 into 6. So then divided by 3. 6 6 are 36 into 2 is 72. 72 pi h to the power 4. Now dv dt, if we do 72 pi 4h cube dh dt. They have given this one as what? 12. 4 into 72 pi dh dt is what? They have given when height is 4 centimeter, how fast the height of the cone increasing? That is h cube we will put as what? 4, and if we put here 4, then it will be okay. First we write 4 cube dh dt. Now calculation we have to do. We cancel this one 3. dh by dt is equal to, it is 3 by 72 into 64 pi. So it is, I think, volume already written. I again want to see this calculation. One thing I found, 1 by 3 pi r cube h. Yes, then it is, no, sorry, r cube now, it is r square. So here small silly mistake, 1 by 3 pi r square h. It is 6 square, so it is 36 by 3. So I think it will be little, I have to change because some small mistakes are there. So 36 by 3 is 12, and it is h cube, not h to the power 4. Now we will little change here, 12 pi 3h square this. Then dv by dt we have done 12 3 into 12, then 4 cube. Little small mistakes we have done, so I am rectifying. So 4 divided by 3 into 12. Also we have to 3 into 12. I will write that 4 cube. That is 64. I did make a mistake. 4 square it is. So it is 16. 3. So it is 1 by 48 pi. And unit also you have to write. As it is given in centimeters, or centimeter per second. So students, this way you will do. I again want to explain. Once sand is pouring, forms a cone. If we take radius as r, height is h, then we get what? One volume's formula of cone is 1 by 3 pi r square h. They have said height is 1/6 of radius, so r is 6 into h. putting r here 6h, that is, as they are mentioning about the height, rate of change of height we have to find. So I have converted r into h, not h into r. So r is what? 6h. After calculation we get 12 pi h cube. Okay. Then rate of change of volume with respect to time dv dt, it's was 12 pi, and h cube's differentiation is 3h square dh dt. dv dt, rate of change of volume with respect to time. First line they said what? That sand is pouring from a pipe at the rate of 12 centimeter cube per second. So with that we put here 12. 3 I have taken 12 pi dh dt. dh dt is the h square is the h they have given 4, I put it, and dh dt we have taken. dh dt we have to calculate. I have taken dh dt here, and 12 by everything I have written. After calculation we get 1 by 48 pi. So you see that way we have to do. So students, I think that much you understood. If you have any doubt, you can ask through my personal mobile number, WhatsApp number also we have. So you think of this one. This is application of derivative as a rate measurer we have taken. So with that we end our today's class.